Hey everyone, how's it going today? Today I have a special video. I'm actually going to be going over another one of these leak code problems in order to help you guys and also me understand more on these problems. So yeah, today we have a doubly linked list problem. So it's called flatten a multi-level doubly linked list. We're basically given a doubly linked list, contains nodes, and the next point, but we get an additional child pointer, and now this child pointer may or may not point to a separate doubly linked list. So here it says these child lists may have one or more children of their own, so it can continuously go down and so on. So given the head of the first level of the list, we want to flatten that list so that all the nodes appear in a single list. So here we can go ahead and check out an example. So it shows that here we have our top parent list, and you see here how it splits off at 3 and brings in a child. And here we go through the child, but also another spot here at 8 we have another child. So that's what it meant when it may have a multi-level data structure. So yeah, basically we're going to go ahead and check what our constraints are. So alright, all levels we need to add nulls in each level to signify no nodes connect to the upper node. Alright, great. So I'm thinking that we should go through, and once we find a pointer to a child, we will set as a head, and then go down, and then go through the entire list. And since it's already pointing to the next, and it's also pointing down to the child, and that points to the 8, we already have some of these taken care of. We just need to be able to get to the 10. Alright, let's go ahead and get right into this. So if our head is not equal, then return head. Alright, let's go down here. So it's basically, if this does not exist, then we'll return the head. Alright, next we're going to want to advance our list till the tail so that we can get this 10. So let's go ahead and do let current node equal the head while the current node is not equal null. Alright, so that's going to go in. We should definitely have our tail, and that should equal our tail dot next continue. And that will be it for the advance till tail. Now, what we're going to want to do next is actually, Alright, so we have our while loop here. Then we have our, this wouldn't we can't exactly do that yet. So if we have the current node is not equal to null, then we should probably put a current node equal to current node dot next. So we're going to the next. Alright, let's go ahead and set up an else. And so this was basically when there's no child, advance forward. Now that's what we're going to want to have. Now what we want to work on is when there's no, or we are going to want to work on new pointer, and then we're going to advance through the child. So let's go ahead and do let tail equal current node dot child, and we're going to want to set up a while loop, and here we'll have tail dot next is not equal to null. Then we're going to have the tail equal tail dot next, and that's where we are trying to search for our tail. All right, let's go ahead and come down. Now that we have that, what we're going to want to do is basically do more of a create like the same type of while loop, but for the tail. So in here, we're going to want to do the tail dot next and have that equal to the current node dot next. If we have that, we're able to set up an if statement. So if the tail dot next is not equal to null, then we're going to want to do the tail dot next, and then it's going to be for the previous, so we're going to do dot previous equal to tail. All right. Now what we're going to want to do is basically a conditional check. So let's go ahead and get current node dot next equal to current node dot child, and then we'll have current node dot next previous equal to current node, and for our last one we'll do current node dot child and have that equal to null. And then at the end, we'll want to just return the head. All right, let's go ahead and take a look through the code. Oh, you know what? We are going to want to set up an if after this. So let's do if current node dot child is equal to null. All right. We're going to want to tab all this over. This should work now. All right, let's go ahead and run the code. It was accepted. Let's go ahead and submit. Looks like we had it accepted. So while we went throughout this for our time complexity, basically we didn't really touch a node more than once, although we did do a current and a tail touch, so that would count as twice, and we're always looking at the worst case. So time would actually be equal to ON. Now for our space, we weren't exactly storing anything, we were just reassigning. So for our space, we would go ahead and get O1. Alright guys, I hope you enjoyed this, and go ahead and test it out for yourself, see how it goes. I'll see you guys in the next video.